Hello everyone, welcome to our pre-calculus pre-recording video. This is our lesson 1 and the topic is rectangular coordinate system, distance formula, midpoint formula, which you will see in the agenda also. Coordinates and graphs, the distance formula and the midpoint formula. So let's start the discussion. First of all, if we want to discuss the coordinate system, we will need to discuss what is the position of an object in one dimension and in two dimension. So let's look at this thing. Suppose if we want to say in this line, let me locate some points. Let's say suppose this is our initial point. Suppose this line is 0. Then if I ask, where is this line? So we can just only say that 1, 2, 3, 4, 5, 6, 7, and 8. That means 8 units away from this 0. Or 8 units, well, this side, assuming this side is positive direction and this side is negative direction in a number line as we do. So, and also if we want to say that from this house, this one is this building, this is also a building, but let's say this is some residential and this is some corporate office or government office. How far they are? If we think it from here to here, then we can just count the distance, like how many boxes are here. So we can find out there how far they are from one another. So if we count anything based on one line, then we call it one dimension. Just only a line. If we consider just only one single line. From that line, on that line, we can just count different numbers. If this is 0, we set the where is 0. Okay, you set where is 0. Suppose we set 0 here, then this is 1, this is 2, this is 3, etc. This is -1, -2, -3, like that. This side is negative, this side is positive. So location in one dimension, to express it, we need one number and a starting point. One number means, as we said, that this is 8, 1, 2, 3, 4, 5, 6, 7, 8. So this is plus 8. The distance from this 0 to this line is plus 8. This line is plus 8. And if we go this direction, suppose 1, 2, 3. So this is -3. So from this starting point, which is our 0, this line is -3. So we can say that this way. This is -3 and this is +3, considering this as 0. And we can set our 0 at some place, or suppose you can set a 0. Suppose if you say, sir, okay, change the 0 from here to, let's say 0 is here. Let's say 0 is this line. This line is 0. Then how far this line is? Then it is 1, 2, 3, 4, 5. Just only plus 5 or just 5. If we say 5, then it means plus 5. Okay. If the sign is not mentioned, that means it is positive. Then let's say if you say, okay, what about this line? Then it is 1, 2, 3. This is -3. If I say, what about this line? Then it is 1, 2, 3, 4, 5, 6, 7. That means -7. Starting point is always here. Okay, so we will have to set the starting point. This is about one dimension. One dimension, if you want to understand the one dimension more vividly, then you can think about some string. I do not have a string here, but I have something like this. So you can think about a string. You see, just only one string, and if an ant walk on this string, then you will see that the ant cannot. If an ant walk on this string, then the ant cannot go up, go down. Just it can go from my left hand to right hand, or right hand to left hand. Just it can move in one direction, either in the left side, to the left or to the right, or it can go somewhat left and somewhat right, but it cannot go up or down or sidewise. Do you understand? Just this is one dimension. This is one dimension. Okay. So then it becomes now when it becomes then two dimension. When it becomes two dimension. Two dimension means like on surface of something. on the floor, floor is a 2-dimension. Just only floor is a 2-dimension. The surface of your table is 2-dimension. Okay, the wall is 2-dimension. Wall of a building is 2-dimension. Just one wall. You cannot consider all of them. Just one wall is 2-dimension. Why? The reason is, let me draw something here, like 2-dimensional something. Suppose this is 2-dimension. You will not have to suppose it. The reason is, see, let's take this one. The reason is, if you want to locate something here, suppose something here, then you see, if this is the starting point, suppose this is the starting point, then you have to go somewhat right, then you have to go somewhat up also. So you have to move to 2 different directions, 1, 2. That's why it is 2-dimension. In this case, you have to move in one direction only. From here, suppose this is 0, then you go this direction, just only, then you get your point. But here, on the surface of something, like your table, like your floor, like wall, one wall, then you have to go to, somewhat right and then somewhat up here, in this example. But you say, sir, okay, this is not my starting point. What about if I start it here? This is my starting point. Then what about this point? In this case, this looks somewhat 1-dimension, because you just go to the right and up and down, left, and up and down is 0 here. So we can just consider it that way. But if we want to locate some point here, then what happens? From your starting point, this is a 0 starting point, then you have to go to the left and you have to go up. So location in 2-dimension needs how many numbers? It needs 2 numbers. In the left how much, and in the up how much. And in this example, in the right how much, in the up how much. Okay, so 2 numbers and a starting point. The starting point in this case is this one, and in this case is this one. So in that 1-dimension, so in the 1-dimension, 1 number and starting point. In the 2-dimension, 2 numbers and a starting point. This is a basic discussion, by the way. This is not something related to this. This is a basic concept of dimensions and how concept develops. Okay, then from here actually we can look at our coordinate system, Cartesian coordinate system also it is called. This is called coordinate plane, or sometimes it is called Cartesian coordinate system, the same thing. This is how many dimension now? This is 2-dimension, because it looks like a surface, it looks like a wall, that's why it is 2-dimension. And on 2-dimensional surface, always you need a starting point, which is 0. This is called the starting point. This is the origin. And then suppose you go here, so you need 2 numbers. One number is how much you go to the right and how much you go to the up. But writing this right side, up side is confusing. That's why the mathematicians, the scientists, they actually came up with some idea. And that idea is, okay, let's write in the right side. For the right side, let's write it is x, and in the up, it is y. So if right side is x, positive x, then left side is negative x from the 0. If right up is positive y, then downside is negative y. This way they thought about it. This side, let me write it down here. This is positive x, this is positive x, and this is positive y. I should write the x like this. This is positive x direction, this side is positive x direction, and this side is positive y direction. This side is negative x direction is this side, and negative y direction is this side. So if we want to go to this point, what we write? We write 1, 2, 3. So in the positive x, we go 3. Then in the up, in the y direction, how much we go? 1, 2. We go 2 unit. So what about this point then? Always we will have to write the x value first, y value second. Okay, this first value is x value, this value is y value. Always. This is called ordered pair. Ordered pair means this pair always follows this rule. Order. First one is x, second one is y. Okay, now see what happens for this point. So to go to this point, you will have to go, you can do two things actually here. You can either go 1, 2, 3, negative 3, then negative 3 for the x, negative 3, you can come to this place which is negative 3. Then you have to go down. So this is 1, 2, 3, 4, negative 4 actually. So then you will have to go to negative 4 in the down direction. So this is one way to come to this point, where you have x value minus 3 and y value minus 4. Okay, alright. Now what if I go this way? Because I can come down first and then I can go left. That is also another way to go to that point. So what happens? I go y direction 1, 2, 3, 4 up until 4. So y value is minus 4. So y value is minus 4. Y value is minus 4. Then I go to the right side 1, 2, 3, negative 3. Negative 3, as you can see, this side is negative x. So then you see x value is negative 3. So basically, this one and this one is same thing. So it doesn't matter in which direction you go to that point, you will get it the same. You will get the same thing there. So this is how we denote some point on the coordinate axis. And suppose now if I give you here this point, then what will be the value of this point? This will be what? Think about it. I will give you answer after 10 seconds. 1, 2, 3, 4. So this will be in the right direction, it is 3, so minus 3. X value you will have to write. Then in the up direction it is plus 3. So y value is plus 3. Plus 3. So minus 3 comma plus 3. This coordinate system actually came from a scientist whose name is René Descartes. René Descartes. This is the name of this mathematician, very talented mathematician, lived only 54 years. He came like 1596 to 1650. So only 54 years he lived, and then he developed this amazing thing. Now you see, let me tell you one thing, a very important thing about this coordinate system, which so that you can appreciate this amazing thing. This coordinate system is super important because this coordinate system connected algebra and geometry. Very carefully notice it. This coordinate system connected algebra and geometry. Before this guy, René Descartes, algebra and geometry was different thing. This is algebra, this is geometry. You have to study them separately. But after this discovery, after this amazing thing, then algebra and geometry now is connected. They are connected. How they are connected? Let me give you an example. Suppose I write here y equals to something, y equals to x plus 2. Okay, some equation. This is algebra. This is equation. This is some equation. And when you have this system, then you can actually draw the graph of this algebraic equation. Then you will have some straight line. Then you will have some straight line somewhere, wherever it is, somewhere. You will have some straight line then. You can graph it. Okay. We will show you how to graph all these kind of things later. But you see, now you can graph it. When you graph it, this is what? This is geometry. But it was algebra. We started from algebra. After graphing, it became geometry. This is a line. Line is a geometry thing. Then it will become curve. It will become so many different shapes we will get. Okay. So this coordinate system is super important. A very significant thing. Also, it looks like a very simple thing, but very significant because of its application is very deep. You know, it connected this two different branches of mathematics. Okay. So ordered pairs, I already said all these things. This side is right, this side is left, left is negative, etc., etc. Up is plus, down is minus. Already we said this 2 comma 3 is here. You can just verify all of them, etc., etc. Okay, all of these things. Minus 2 comma minus 2 is there. And what is the ordered pair for this point? For this point means this starting point. What is this ordered pair? So this will be what? X value is 0, y value is also 0. That means this value is 0 comma 0, this value. And this is called origin. This is called origin. Now how long is this AB? Now we are discussing the distance. See, you can just count it. 1, 2, 3, 4, 5, 6. So the distance from here to here is 6. Okay? Or you can do it another way. You can write, okay, 4 minus, then this is minus 2. This is minus 2. So it becomes 4 minus into minus means what? Plus. So total is 6. So the distance is 6. Once again, let me repeat. How much is the distance from A to B? 1, 2. This is 1 box, 2 box, 3 box, 4 box, 5 box, 6 box. The distance is 6. So you can count it this way. Or you can look at their number. Okay, this is 4. And this one is what? This is minus 2. So you subtract it. To find out the distance, you always subtract. Bigger value minus a smaller value. Bigger value minus a smaller value. Then we get the distance. Okay, we get their length. And then this one also similarly we can do this value minus this value, then we will get the distance. Or we can count the box. 1, 2, 3, 4. Here it is 4. And how can we do this mathematically? 6 minus 2. 6 minus 2. Answer is 4. So this is 4. This is 4. This is how much? This is 6. Okay. So see, x2 minus x1, y2 minus y1. This is our x value, x value. So x2 minus x1, and this is the y, because vertical is y, horizontal is x. So this will be y2 minus y1, and this will be x2 minus x1. This way, this is like mathematically we can write it this way. This is another mathematician, very talented mathematician, Pythagoras. You may have heard this guy's name many times. He's a Greek mathematician and a cult leader. That means he is the leader of some group of people, special, very one-sided kind of. Thought that beings were evil. These are like some interesting information about this guy. And he killed another mathematician who proved some number couldn't be written as fraction. That means about the irrational number. So this is that guy, Pythagoras. But he has this amazing formula which is called Pythagorean Formula. C square equal to a square plus b square. C is the hypotenuse, length of hypotenuse. A is the length of one side of this right angle, another side is b, and c is the hypotenuse. We cannot say this base, this perpendicular, because the angle is not given. That's why. So we will call it one side. We will call it another side. So sum of two sides is square equal to the hypotenuse square. Very significant. It also looks very simple, but very important. You will be using it in many places. This is the famous Pythagorean formula. Very famous, very famous. Okay, we are back to the same figure because we will actually try to establish a formula here. So what is the distance between A and C? See, there is a interesting problem here. So I said that this is 1, 2, 3, 4, 5, 6. So 6 boxes away. That's why the distance is 6. But what about this one? This is like 1 box. Then there is like how much? Half or 1/4 or 1/5? How much? This is very small part of the box. Then you see this line is not following the box. You see, There is a problem here. Okay, there is a problem here. So when the line is not vertical or horizontal, this is vertical. Vertical means up. When we stand up, we are vertical. When we sleep, we are horizontal. Okay. So when a line is vertical, then it's easy. We can count the box. When it is horizontal, we can count the box. But what about if the line is not vertical, not horizontal? It is inclined somewhere like this, inclined, somewhat inclined. Then what about that? Here comes our distance formula, which helps us very, very well. This is a right angle triangle, so we can use that formula of the right angle. You see? So we have this value and this value, so we can easily find out this value, because c square equal to what? A square plus b square. C square equal to a square plus b square. So we can use his formula to find out this distance. So ac square equal to c, a square plus b square. You get this. So the answer will be ac equal to what? Then square root of 52. Is equal to square root of 52. We are not giving here plus minus because this is distance, so distance will be definitely positive here. That's why. Now we can make a formula. You see, we can give this point as x, and you can consider this one x1 y1 and x2 y2, or in reverse order also you can do. You can say this is x1, this is y1, this is x2 y2 also. Formula will work. No worries about that. Now we can actually write it in terms of formula. So the distance from this point to this point will be x2 minus x1 divided by y2 minus y1 whole square. x2 minus x1 whole square plus y2 minus y1 whole square, then is square root. This basically, this whole thing is what we have written here. This is a generalized thing. Okay, this is a generalized thing. Notice that, let me show you. Notice that this point, this 4, how we get this 4? How we get this 4? How we get this 4? We get this 4 from subtracting 6 minus 2. So that means if I write here, say this one, just let's follow this same trend. We can prove it other way also. x1, y1, suppose this is x2, y2, comma, y2. Oh, I don't want to make it bigger now. So x2, y2. So what we can do is, this is actually the same value. This y1 is actually same value. This is 2, this is also 2. So basically we are doing y2 minus y1, which will give us 4. Same value. You see, this line is same. This is 2, this is also 2. And to get this distance, actually we will have to subtract x2 minus x1. This is our x2, x line. See, this is the x line, x2 minus x1. So basically this 4 is y2 minus y1, and this 6 is x2 minus x1. Then by using the Pythagorean formula, there is a square, so we will have to square it. Then there is a ac square in the other side, so we will have to square root in the right side to bring it. That's why we get this formula. That's why we get this formula. Just 10 seconds. All right, I'm back. So yeah, that's why x2 minus x1 whole square comes from here because of this whole square, and whole square, another whole square comes for this part, and there is a square in this side, ac square. When this square goes to the other side, it becomes a square root. This is how we develop this formula. Okay, this is how we develop this formula. We'll try to practice this math in class. So this is in class practice. Now let's discuss about the middle point. What is the midpoint of this line segment? What is the midpoint here? So when you have this kind of when we have this kind of easy problem, we can just think about, okay, this is 1, this is 1, this is 1, this is 1, and midpoint is somewhat in between this and this. Okay, somewhat this in between this and this is midpoint. Let me show you once again. So you see this one cancel, this one cancel. So middle point is somewhat here, and this middle is somewhat here. This is some kind of intuitive way. Intuition is this. Okay, this is this part, this is this part. Okay, middle is in here, like that kind of thinking. But mathematically also we can do it. Mathematical process is easier. So you have two numbers. One number is this, another number is this. To find out the middle point, midpoint, what you will have to do is you add this number and then divide it by 2. Because it is middle. Middle means this and this, then divide by 2. Okay. So you have minus 3, then you add 2, then divide it by this 2 is this one, then always divided by 2. So answer is, you see minus 3 plus 2 means minus 1, then divided by 2. That means 0.5 minus 0.5, and minus 0.5 is here. In between minus 1 and 0, then you have that minus 0.5. Okay. Now let's say we ask you another question. Let's say our question is, what is the midpoint of minus 2 and 4? Okay. So you see, to get the middle point, okay, let's cancel out. This is cancelled with this one, then this is cancelled with this one, then this is cancelled with this one. So middle is here. It looks like middle is here. Without doing the math, we understood that middle is at 1. Now let's do it mathematically. So our rule is we will have to add these two numbers and then divide by 2. So minus 2 plus 4, then divided by 2. So we have this is minus 2, then plus 4. So we have plus 2, then divided by 2. So answer is 1. This is the 1. So middle point is 1. So that means to find out the middle number, midpoint, we will have to add these two numbers and then divide it by 2. And same thing will happen here actually. Just the difference is you will have to add x1 plus x2 divided by 2, then y1 plus y2 divided by 2 to get the middle point here. That's the only difference. Okay, like this, average. So to find out the midpoint, we will have to do x and x. x2 plus x1 divided by 2. It doesn't matter which one you write first, okay? Because as you know, 2 plus 3 and 3 plus 2, same thing. Same thing. So it doesn't matter which one you write first. x1 plus x2 divided by 2, y1 plus y2 divided by 2. Just this one plus this one divided by 2, comma, y1 plus y2 divided by 2. Notice this is, it doesn't matter which one you write first, like x1 you write first or y1 x2 you write first. But it is sensitive that you will have to write all the x first, then y. Because in our ordered pair, we will have to follow the rule, as I said at the beginning. X always first, then y later. And then x1, x2, you can switch. It doesn't matter. Okay? So this is how we can find out the midpoint. So how to find out the midpoint? You add the numbers and then divide it by 2. For x value, for the y value, same rule. Okay. Then during the class, we'll try to practice it, and you can try to practice this math from the book. Optional, we have an optional challenge problem, page number 4, question number 60. Try to solve this math. And in the answer section of our book, you will actually have the answer of this maths, so you can practice these maths as well from there. I think that's all for today's class, and thank you all. Thank you very much for watching this video, and we'll see you all in the class. Have a nice day. Thank you very much. See you all. Bye.